So we go to question, oh, there was a suggestion that what if we assume that this question has come like it came in the other paper, that they asked us to find the term if they ask us to find the term in x power 4. So if they say if the term in x power 4 is equal to 68, find y. Okay, so the term we're looking for is in x power 4. So then what will happen is we'll take it as if we know nothing about the term. And this will be a, n minus r, and b r. So where there is n, we have 6. And then we have x. And then we have minus y. And then we have x minus r. At this point, we will say we want x to the power 6 minus 2r to be equal to x to the power 4. So that 6 minus 2r is equal to 4. And so we'll have minus 2r is equal to minus 2, so that r is equal to 1. So we'll go back and say, okay, so 6 choose 1, x power 4, and then minus y. This was power r, so we'll say minus y power 1. Then we would have said equal to 68. So except that when x is involved also, then we may not actually find the actual value of y. But we know that 6 choose 1 is 6. So we would have said then minus y x4 is equal to 68 divided by 6. Like that. And so we'll just leave it here because we cannot find the actual value of y. But the idea is, should they ask you to find the term in x power 4, then you would put the powers of x together and equate the power of x to 4, because they want it to be 4. So find the other that will make it be 4. I think that's the idea of the question. I hope it clears the minds now.
Thank you, sir.
All right.
Sir,
Yes.
yeah, I have a question, but not based on this, but something like this, like when you're finding the independent value of x, when you
The
get
independent term of x.
yes. So like hello,
Yes.
when you equate the way you're equating, also when finding the independent term, you also forget about the x when you find r.
When you find r, the term you're finding r, you leave x there, is it? You leave x there. When you go to find r, you leave x. You just pick the powers. And then you find the value of r. If you were saying you want the term independent of x, then when you go back, there will be no x, because the r you have found is actually making x disappear. It's making the power of x 0. So x power 0 is 1. So it means that you won't have x in your remaining expression.
Thank you, sir.
You're welcome. Okay, next question. It says, consider the function. So this is 4a. consider the function f of x, which is defined as a piecewise function, 2x, if x is less than 0, 1, if x is equal to 0, and x squared if x is greater than 0. Yeah, disabling. Put one. Put one. Put one. Go. Okay, so the question says, show that f is not continuous at x is equal to 0. Show that f is not continuous. So you are told it's not continuous. Your job is just to show. So then you would want to solve as if you think it's continuous. Okay? Or you are checking for continuity. Then in the process, you will discover the reason. Mommy. So let's find the steps. So we say 1, we know that we must check what f of 0 is. So what is f of 0? So f of 0 is, as defined here, when x is 0, we get 1. Okay. Then part 2, we find the limit as x approaches 0 from left of the function. So if you find the limit as x approaches 0 from left of f of x, we use the function that comes with less. So as x approaches 0 from left, we'll use the function 2x. Because it's one that has x less than 0. So this will be 2 times 0, which is equal to 0. And also find the limit as x approaches 0 from right of f. That is the limit as x approaches 0 from right. The piece we pick now is the one that has x greater than 0. So we have 0 squared, which is equal to 0. Now, what it means is that if the two side limits are equal, then we have actually found the limit as x approaches 0 of the function f to be equal to 0. The third part is the one that checks if there's continuity or not. Because now we are going to compare the limit as x goes to 0 of f of x. Is it the same thing as f of 0? The answer is no. Because the other one is 1, and then the other one is 0. So if the answer is that the two are not equal, then we say f is not continuous at x is equal to 0. And that's how we check. So whether they say check that is continuous or they say confirm that it's not continuous, you do the same thing, except you just, in your solving, you are giving reasons as to why you're saying it's not continuous. Then now, they give us a task, okay? They have said, okay, since you have managed to show that it's not continuous, can you now redefine it so that it becomes continuous? So to redefine f, to make it continuous, you must make sure that the limit as x approaches 0 of f of x should be equal to f of 0. So now, since the limit cannot be changed, we can change f of 0. So we'll force f of 0 to be equal to 0. Okay? So that our function f will now be defined as 2x if x is less than 0. We will define it as 0 if x is equal to 0, and then x squared if x is greater than 0. So that when we say f of 0, we must get 0, which is the limit. So always when they say redefine, you go back to where the problem is. The problem is that f of 0 was not equal to the limit. So you make f of 0 be equal to the limit value. The second step is to find the limit from left and from right. How do you find the limit from left? You pick the function that says x is less than. Also find the limit from the right. You pick the function which says x is greater than to find those values. If they are equal, then now you have found the limit without a plus or a minus. Here. Okay. So if you're asked to redefine, please take note that you cannot change the value of the limit because the limit we calculate from left and from right. But the f of 0 is just mentioned when x is that, let it be 1. So if you want any changes, you go there and change it. But if you cannot find the limit, they cannot even ask you to define it. Because if the limit does not exist, then the function cannot be continuous, or whatever you do. That was the question.
Yes, I actually answered my question. I wanted to ask about the limit can exist, but again, not to be continuous, but just after this.
Oh, okay, good. Okay. Where is the body? That's it. Okay, let's go to B. Mathematics, you don't know mathematics. So B says find dy dx. Part 1. Y is equal to the root of x squared plus 1 over x plus 1. I know. Yeah, disturbing me. Go. So we write this as x squared plus 1 to the power half. And then divide by, we expand it to be x squared plus x. So at this point now, it has become, okay, so it's a fraction anyway. So how do we differentiate fractions? We use quotient rule. So we let u be equal to x squared plus 1 power half. And v to be equal to x squared plus x. Then we differentiate u prime. So to differentiate this function, we use chain rule, meaning we bring down the half and maintain what is inside, and then subtract a 1 from the half, then multiply by the derivative of the inside, which is equal to 2x. So this alone now becomes, this 2 and that 2 can cancel. So we have x multiplied by x squared plus 1. Half minus 1 is minus half. So we can write this as x divided by the root of x squared plus 1. So since the power now is negative, you can take it in the denominator to become positive, and then half is just a root. So we go and differentiate v as well. Using power rule, this will just be 2x plus 1. Then now we go and find dy dx. So dy dx is actually equal to u prime v minus v prime u over v squared. That is u prime, we have found it. It's x divided by the root of x squared plus 1. And then v is 2x plus 1 minus v prime is 2x plus 1 multiplied by u, which is the root of x squared plus 1. And then we divide everything by x squared plus x to the power 2. So here we made a mistake. We're supposed to multiply this by okay, so we're supposed to multiply this by it by x squared plus x, because we are multiplying it by the original v. So this will be our answer. So we just need to be careful, especially on the chain rule. Because chain rule, you differentiate the power alone first and write everything. And just the only thing you change is that in the power you subtract a 1. Then now you multiply by the derivative of what is inside the brackets. So the methods, if you have a fraction, is quotient rule. If you have a product, it's product rule. If you have some power and you have the brackets and some power, you use chain rule. If it's just to open, you use power rule. Next question. This I'm not sure if you guys did the derivatives for these. Did you differentiate them, the logs? Is there a tool sheet where we're differentiating the logarithms from 4 up to 10?
No, sir. No, we don't have a spreadsheet on derivatives of logs.
Okay. So you may not be asked to do that, eh? No. Okay. So then let me change the question here. We say the previous slide. Okay. I guess you're done. Good. So then let me change the question then. We'll read it as find the tangent, find the equation of the tangent to the curve y is equal to x squared plus 2x minus 1 at x is equal to 3. So find the tangent equation to the curve y is equal to x squared plus 2x minus 1 at x is equal to 3. So if they ask you to find the tangent equation, your job is first to find m, which is a gradient, because we know that the line should be y minus y1 equal to m x minus x1. So let's first find m. So to find m, you find the derivative of y, which is 2x plus 2. And then where there is x, you substitute the x value given. So we get 8. So it means that m is equal to 8. Okay. So m is equal to 8. Like that. Then one more thing you do is you go to the original function. Where there is x, substitute 3. To find the y coordinate. So we have 9 plus 6 minus 1, which is equal to 14. So that is the y coordinate. When x is 3, y is 14. So now we have y minus 14 is equal to 8, x minus 3. So you can simplify this if you want. That is.
Yes, sir. So when getting the y-intercept, we're not supposed to equate the, to substitute where there's x0. We need to, like,
We're not finding any intercept here.
oh,
We're just finding a full point that we want to use. Remember, for n line, you need a point.
yes, sir.
So, from this question that we are doing, what's the difference from that one that we are doing in the tutorial sheet of m is equals to mn is equals to 1 of an perpendicular line?
So that one, so this one is for the tangent. That was saying find the equation of the line perpendicular to the tangent, meaning we're looking for the equation of the normal line. So if they asked for the normal here, would have said mt m normal is equal to -1. Since mt is 8, then we would have found m normal to be -1/8. So we are going then to substitute where there is m, we're now going to use -1/8. Everything else would have been fixed. So we would have said y minus 14 is equal to -1/8 x minus 3. So now, since the time we are remaining with is not much between now and the test, you need to simplify your study. Pick a concept per part that is part of the coverage. So you see, if there's, there are trig graphs, just understand sine and cos. It doesn't mean that you should solve for both sine and cos. Just solve one. The other one will follow, of course. You do one graph of log, one graph of exponential. You do one equation on log, one equation on exponential. You do one, like, okay, let me see how they do equations of trig. How do they find angles? How do they sketch log, exponential? How do they sketch modulus? How do they sketch radical? How do they sketch a rational function? How do they solve the inequalities? So each part you do one.
Sir,
Hello.
yes, I was just asking, like, can we do some, like, one question on trigonometry equations?
One question on trig equation. We can do the simple one. Like, solve sine 2x is equal to half. What? So like that one. So this, and then we also do one like this. Cos x, cos squared x is equal to 1/4. Yeah. So the idea is you solve. Maybe you are solving some things, then you arrive at this. Or they ask you such a thing direct. The idea there is they want you to find the values of x that when you put here, the angles that value will be making will give us half in x. So as what we know is that in the first quadrant, there is an angle that gives half in sine. And the angle is 30. In the second quadrant, the angle is 150. But the x that we have has been multiplied by 2, meaning I'll go back to the first quadrant and add 360. I'll get 390. I'll go to the second quadrant to 150 and add 360. Okay. I'll get, what do we get here? That is 460 plus 50. That's 510. You see? So these angles we get. Now we bring back our 2x and equate it to 30, meaning x is equal to 15. We bring our 2x and equate it to 390. So to find x, we are dividing 390 by 2. That is x in there. Again, we get 2x and equate it to 150, meaning x is 75. We get 2x and equate it to 510, meaning x is what? 255 degrees. So it must read as 55, it's just difficult, right? Maybe let's try 255. You see, if you are given cos squared is equal to 1/4, you make cos a subject by square rooting. So you get plus or minus half, meaning we'll look for the x that gives us half, also the x that gives us minus half. So for half, we go to the first and fourth quadrant. That's where cos is positive. In the first quadrant, it is 60, where cos is half. In the fourth quadrant, it is 360 minus 60. So we'll get 300. Cos is negative in the second quadrant. Okay, that will be 180 minus 60 in that quadrant. So we get 120. In the third quadrant, cos is negative. So we'll have 180 plus 60, which is equal to 240. So you always watch out when you're in the third quadrant. Because in the third quadrant, there are times when you subtract and times when you add. If the angle you have found is a 60 from the first quadrant, and you need an angle that belongs to the third quadrant, you add the angle you have from the first to 180. If you are having 240 and you're looking for the angle that lies in the first quadrant, you subtract 240 minus 180 to get 60. You never use 270. So that's the idea there.
Okay, thank you, sir.
And please don't panic tomorrow, right? The test is for you. When the test is yours, they are testing you. It's you they want to answer. In fact, they're just asking you, do you know this? That's a test. So why should you be scared? Well, you're just there to be asked. What you know? Do you know this? Yes or no? If you know, how do you know it? You explain. Not that thing where you sit, someone wants to ask you a question, then you are shivering. Are you guilty? So take your time tomorrow. That test is your level. It's for the
Sir.
test. Yes.
Sir, can you help us with tutor sheet 7, question 5?
What does it say?
I don't know how to read it. It's about the summation of something for binomial. I've sent it in the group.
My heart is telling me that it's just a fear. Let me look at the question. The question says, using the result in question 3, show that the sum of that will give you n plus. Will give you n plus what? So what does the identity say? Part 3 says that if you have n r plus n r minus 1, what you get is n plus 1 r. So want to use this, okay? We are given the summation r is equal to what? R is equal to 0. Up to n is equal to 1. The summation of r plus 1, 1, which is equal to n plus 1, 2. So it says, using that result, show that. So what does this mean? This means that where there is r, put 0 first. So you pick your left-hand side. Where there is r, put 0. So we have 1, 1. Plus. Where there is r, put 1. So we have 2, 1. Like that. So they are saying in fact, he has even confused the question a bit. Yeah, a bit confused because the R is moving when it's not supposed to move. Okay, so if I'm given this, then we should show that this guy is equal to what? N plus 1, where n is equal to 1. So here there's a problem. A bit. Because then my R needed to move from 0 to 1. But it can't move when n is static on the other side. Oh, okay. Or we write, let's write this one like this. As n plus 1 r minus n r. So that it gives us n r minus 1. Like this. So that here when we replace, you will have 2. If we replace x to be n to be equal to 1, then we'll get 2, which we can try to write as 2 minus 1 to give us 2 Does it make sense? It doesn't, because of this value here. So I think this n is not well defined on the right. So it's making it a bit ambiguous. So I need to check the n properly.
All right, sir.
All right. Anyway, so this thing will be cutting soon. When it cuts, there will be no rejoining. Start well. I'll figure out this and I'll send, if it makes sense, then I'll update you.